Welcome to this explainer. Today, we are going to break down exactly how the Papyrus Deckle Optimizer solves the notoriously complex cutting stock problem for Indian paper mills. We're going to do a comprehensive walkthrough of the whole shebang, from trim loss minimization to deckle planning and slitting schedule generation. If you are anywhere near the manufacturing side of the paper industry, you know exactly what I'm talking about. You've got these massive parent rolls of paper coming off the machine, and you need to slice them into narrower rolls to meet specific customer orders. How you plan those cuts dictates whether you're maximizing your profit or literally throwing your raw materials straight into the trash. So we're going to see how advanced algorithms are turning this from a manual nightmare into a streamlined, automated engine for profitability.
Here is our roadmap for today. We're going to look at India's booming paper market, define the trim loss problem, meet the Deckle Optimizer, check out how the algorithms actually work, dive into shift planning, and finally, look at driving mill profitability. Let's just jump right in.
Section 1. India's booming market and paper market growth.
To put things into perspective, India's domestic paper market is absolutely surging right now. Data from the Indian Paper Manufacturers Association in 2024 projects a massive 23.84 million metric tons of market size for the 2024 to 2025 period. We are talking about the fifth largest paper producer in the entire world, representing about 5% of all global production. The momentum here is staggering, with total production having roughly doubled over the last decade.
And honestly, it's not just growing steadily, it is accelerating. In fact, it's the fastest growing paper market globally. This is largely driven by an impressive 8.2% jump in packaging paper and paperboard consumption alone over the last year. But, well, here's the catch. When you are producing at this breakneck velocity, tiny margins of error compound into massive financial losses.
According to the Central Pulp and Paper Research Institute, you've got about 526 operational mills out there scrambling to meet this soaring demand. And the reality on the ground? A significant portion of them are still trying to run these incredibly complex manufacturing operations using manual spreadsheets and basic accounting software. Imagine trying to solve a 10,000-piece puzzle completely blindfolded. That's kind of what these planners are up against every single day. The market has totally outgrown the tools many mills are using to manage it.
Which brings us to Section 2, the trim loss problem, or the cost of waste.
Think about it. Every single time a massive parent roll is sliced on the slitter rewinder, the leftover edges, the trim waste, are just cut off. Because, let's face it, customer orders rarely add up perfectly to the exact width of the parent roll. So you end up with these completely useless offcuts. You are literally watching your raw material, your energy costs, your machine time, and ultimately your profit get sliced off and thrown right into the recycling bin. It's a mathematical puzzle that human brains and basic spreadsheets simply cannot solve optimally at scale.
But it absolutely doesn't have to be this way. Published industry research from Applied Sciences back in 2020 shows that mathematical optimization can slash this trim loss down to around 2.2%. That is the gold standard for an optimized make-to-order paper mill. Getting down to those numbers manually is virtually impossible, sure, but with the right technological engine, it is a totally achievable target that directly protects your bottom line.
So let's meet that engine in Section 3, Meet Deckle Optimizer.
The contrast here is literally night and day. We go from hours of stressful, manual spreadsheet math, where a planner is just desperately trying to find a good enough combo so the machine doesn't stop, to literally minutes of automated planning. The Papyrus Deckle Optimizer reliably drops trim waste by 5 to 15% on average compared to those manual methods. Just think about what a 5 to 15% reduction in raw material waste means for a mill's profit margins over a whole year. Plus, it frees up your production planners for much higher value activities instead of being bogged down in endless spreadsheet permutations.
Let's move on to Section 4, how the algorithms work under the hood.
It is a really clean, highly intelligent four-step flow. First, you just feed in your machine specifications and customer order demands. Second, the system unleashes these heavy multi-tier mathematical solvers. It uses greedy algorithms, MILP, which stands for Mixed Integer Linear Programming, and Metaheuristic solvers. In plain English, it basically acts like a chess grandmaster, calculating millions of moves ahead to find the absolute mathematical peak. Third, you preview the generated patterns in real time, test them, and use the approval workflow to select the best one. And finally, in Step 4, it generates the optimal slitting schedule and pushes that perfect plan straight to the floor, exporting it to PDFs for the operators.
And the real brilliance here is how it handles the complex, messy realities of a real mill. It doesn't just do theoretical math in a vacuum, it enforces strict business rules. For instance, applying grade and GSM minimum quantity constraints ensures you aren't creating unworkable, micro-sized rolls that your operators will absolutely hate. Crucially, it maps out the specific winder and cutter equipment downstream, ensuring the cutting pattern is physically executable by your actual machinery. It also allows for single and multi-pattern optimization across multiple parent rolls, and even saves the best setups in a pattern catalog for easy reuse.
Section 5. Planning and Analytics for Floor Management.
Because proper decal planning requires sequencing these cuts intelligently across a demanding production shift, right? This module takes the optimized patterns and schedules them as sets of rolls across a specific work shift, meticulously tracking changeover times. What I really love here is the surprisingly pragmatic standalone CSV import mode. If a rural mill floor completely loses its internet connection, the system doesn't just freeze, it still works perfectly. Furthermore, it gives management a comprehensive analytics dashboard. You can track trim analysis, shift summaries, and plan versus actual performance, alongside complete audit logs for quality control and regulatory compliance.
Finally, Section 6. Driving Profitability and Financial Impact.
When you integrate highly specific paper industry modules like the Deckle Optimizer into a unified platform, the financial impacts are profound. The Aberdeen Group's benchmark study notes that best-in-class manufacturers utilizing ERP systems achieve a massive 19% reduction in operational costs, alongside a 20% reduction in inventory levels. You aren't just saving paper here, you are fundamentally shifting the cost structure of the mill by eliminating waste, accelerating planning from hours down to minutes, and enforcing data-driven accountability across the entire floor.
With India's domestic paper market growing faster than anywhere else on the planet, production scale is only going upward. Relying on wasteful, manual planning spreadsheets is no longer just a minor inefficiency, it's a massive financial leak. So I'll leave you with this. In an industry where every single millimeter counts, can your mill really afford to keep leaving profit on the cutting room floor? Thanks so much for joining me on this explainer, and we'll see you next time.